So when I originally wrote the Frognet code, when I wrote the first Frognet code, uh, I wrote it in Bash, and I wrote in Bash because that's the way you control a network, right? You use IP this, IP that, and you use route commands, all kinds of things like that. But it's all Bash. It's all just done from the command line. I wasn't doing anything weird. I wasn't doing anything out of the ordinary. But over time, it became too complex, right? The scripts became huge, and the branching was untenable. So I wanted to do more with it anyway. I needed more validation, more verification, the ability to be more flexible in how I tested the thing. So it was pretty obvious that it needed to be redone and redone in Python. So we did that and got it all working again. We retained the bash shells. They're still in user local bin, but the code itself was moved into slash op slash frognet schematic slash discovery, and from there we do everything that used to be done in Bash. Moving it into Python gave us one other advantage that was huge, and it was intentional. It lets me run a simulator for the actual code that is running. Now, when I talk about a simulator, I don't mean, like a test harness or anything like that. I mean an actual simulator. I used to work for Boeing in the engineering flight simulation department, and I worked on the autothrottle with a guy named Stan Lefevre, an autothrottle for the 737-300 aircraft. And we would take the autothrottle out of the aircraft and put it on the bench and drive it with a simulated aircraft and a simulated world around it. In fact, the simulation had three formal levels. Level one was the world, the general rigid body equations of motion, the atmospheric model, gravity, things like that. Level two was the aircraft that you were simulating. So my level two was a 37-300. For other people, it was a 47 or 27, 57, 67, whatever it was. That's your level two, and that defined the engines, the landing gear model, the flight dynamics, things like that. And then level three was whatever component or subsystem you were working on. So for me, that was the autothrottle usually, sometimes the autopilot, flight management computer, but usually the autothrottle. And in level three, I would have my simulation of it, and Stan would have his implementation of it in the real thing. Stan would provide me with what we call control law diagrams that I would implement, and then we would validate them. That gave us a way to prove that what was on the aircraft, what was going up, was actually the same thing that we were running when we were doing simulations and trying to certify the auto throttle using our simulated code rather than using the hardware, because the FAA would let you certify a piece of a system like that if you landed it in real life a few hundred times, or if you landed it in a simulator a few thousand times. And it's a lot cheaper and easier to do it in a simulator than depending on Mother Nature and things like that, and trying to do it in real life. So that to me is what a simulator is. It exercises real code, and that's what the Frognet simulator does. The Frognet simulator simulates the environment that the code executes in. It simulates the kernel routing. It simulates the protocol movement, the data going from socket through to other socket. It even has a MySQL shim. And in all those cases, what it's doing is just providing the support, the environment for you to run whatever tests you want to run. And the simulator is it's comprehensive. Um, there are actually two separate simulators in there. One is sort of a precursor. I don't want to say it's a simple one because it's not. It's a true simulator and it's executing truly is executing the code, but it's not as complex as the full system simulator. This one is in discovery and it's used as part of the discovery validation process. So if you go to discovery, so you go to prognet semantic / discovery and you look in there, there is a run discovery oracles.py that's in here. And I thought there was another one in here too. Some of these are you can see like identity pre-flight. Those are ones that are used during the system process uh, to to make sure that the system is up and running right. So anyway, we're going to run the discovery oracles here. So we're going to do a Python and just run discovery oracles. And there we go. So what it's doing is actually making sure, based on running the real code, which is in adjacent directories here, right? Adjacent under frognet semantic, they're adjacent, uh, and it's making sure that everything is going to be working out the way that we expect it to. So this one gives us confidence that the the fundamental uh, the fundamental operation of the network is correct. That we can do routing, that we can do name lookup, and that we can split and merge, things like that. So all of these happen automatically, and they happen over a topology, a system of 23 different network topologies. So we're going to let this one finish, which I hope it does in a second here. There we go. So we're going to let this one finish. That is the discovery gate. And so 79 oracles plus one known failure. So 80 oracles, 80 actual tests in here. But at this point, we know that the system is appearing to be nominally correct. So we then go over to simulation. And in here is a much more comprehensive simulator that actually uses the proxy and the daemon code and the tunnel code. And this one has the way of simulating the WireGuard tunnels. Uh, Actually, I think that's in the other one too. But getting things through the tunnels and being able to coordinate them, and because we are simulating the environment and not the code, you can add your own stuff into here. So if you've got your own, I test the communicator by using this simulator. That's one of the ways that we do it. So the simulation itself can be used for all kinds of things. And the easiest way to get to it, the easiest way to get started with is just say Python 3 run simulation or run all. Sorry, Python 3 run under all.py. And it's going to go out and it's going to do the same thing that the Discovery Oracle did, only on a much broader, larger scale. And it's going to do it in tiers. So you'll be able to see how it does this as it moves forward. Here is running in tier 5. It's actually running the semantic data plane, which is the true transport. Codex language compliance. We make sure that it handles all of the various uh, uh, differences you can have. All the various syntax possibilities for for the languages that we have, and then over some various transports. Now, the thing about these Oracle or these simulators that I want you to understand, and I know I sound like an AI when I say that, is that these were designed for you to use with AI assistance. Okay, this is an extremely complex system, and being able to hold it in your own head in its entirety is difficult. It's difficult even for the AI to hold this thing in its head. Trust me, I know that for sure. But in terms of the oracles, in terms of the simulators, this is something the AIs have been able to get their heads around uh, with pretty good success. And so if you use the AI and you say, I want a new topology of XXXXX, it's probably going to be able to put that in a lot more quickly than you would be able to do it by hand. Or if you want to say, I want the simulation to test out this feature, again, I think you're going to have a lot more success with that uh, doing it doing it with the simulator than and using an AI than trying to do it by yourself. So a lot of what I did in FrogNet is AI assisted, and I admit that. Uh, and you know, I have no problem with it. The code works, and I can say it works, and I can prove it works. So I'm okay with AI assisted code, obviously. But to know that this has been specifically created for you to use with AIs, because I believe that AI assistance is probably one of the big things that's going to go forward, and being able to use AI assistance in ProgNet from the beginning, having it designed in from the get go, is important to me. So you can take the simulator, you can do pretty much anything you want to it. You can give it different topologies, you can give it different hardware, software, anything, and it will deal with it. And if you use the AI, you can set up different topologies. You can modify the simulator to do different things. You can use it when you're building and configuring your own bundles, your own packages, all that kind of stuff. It's an extremely powerful tool, and it is in fact what I encourage you to use if you believe that you have got something that is breaking FrogNet. Do it in the simulator. Give me an oracle that turns things red, and let me look at it, and then we can figure out how to fix it from there. So that's the simulator. Just want to get that out there. Make sure that you use it, and make sure that you understand what it is that this thing is doing across the board, because it ain't easy, but it's awesomely cool. All right, later, man.